Hi everyone, this is a circuit. It's a combination of series and parallel capacitor actually. So in this circuit, they ask you find out different parameter basically, what would be the equivalent capacitance across the point A and C, what would be the charge, what would be the individual voltage and the charge of this capacitor. So they give you that information. C1 and C2 basically C1 and C6 is the 3 microfarad, C3 C5 equal to 2 C2 and 2 C4 equal to 4 microfarad, and this voltage actually the 20 volt is equal to that one. Then they are asking me to find out the equivalent capacitor, equivalent charge, and then voltage across that capacitor C1, charge across that capacitor which is Q1, and similarly V2 Q2 and V3 Q3 across this capacitor. And they will also ask you another question: what is the potential difference between B and D? Fine. To solve this one, I'm going to draw a simplified circuit of that one. Look at this. I can draw this circuit in that form. Alright, say I'm drawing over here. Say this will be easier for me, so how am I going to find out that one? Say this is my voltage, which is the 20 voltage. Over here, look at this is my C4 capacitor, right? And I can draw, say this is C5, this is actually C3, they are in series, they are connected to a point, and this is actually I can draw is a C2, right? They are also connected in that point. This will be the same. And what about over here? This is actually that C6 capacitor. This is actually that C1 capacitor. They are connected another point, which is the node of that one. Or I can also label, say this is actually that your point A, this is actually your point B, and this is actually your point C. That should be basically that equivalent circuit of that one. Then I can say I have to find out the equivalent capacitance between the point A and C. Then I will be also able to find out the charge, right? Then I can say C2, C4 and C3, C5 and C3 basically the series. With respect to that series, C2 and C4 are in parallel across the node A and B, and across the node B and C, C6 and the C1 in parallel, and these two parallel would be basically in series. So that means I can also modify one more step of this case. I could draw, this is the, in that case, so this is actually the total voltage. I can write, so this is basically the equivalent of this capacitor. This is one equivalent of that capacitor. So I'm going to write, so this one actually the equivalent of it's not a V, 2, I'm sorry, we should write in the capacitance equivalent. This will be the C equivalent of 2, 3, 4, 5, and this is the equivalent of capacitance 1 and 6, and they are in series again. Then this equivalent would be, you can draw one more line. So this equivalent would be in basically equivalent capacitance of C equivalent. That's thing they are going to ask. If I could find out the C equivalent, they will be also, I'd be also able to find out that Q equivalent. So this is actually the first and second question they are asked. Fine. Then I'm going to find out this step by step. What would be the case? I can write, say, question number 1. First, I will find out the equivalent of these 2, 3, 4, 5, right? They are also series and parallel combinations, so that's why I can write. In the parallel, I know that I have to add them together, right? So if I write down C2, 3, 4, 5 at a time, what I can write is C4, and C4 basically your 2 microfarad, right? C1, C6 is the 3, C3, C4 actually the 4 microfarad, but the C2 would be the 2 microfarad and C4 would be also the 2 microfarad. Basically 2 C4 actually the 4 and 2 C2 actually also the 4. So that's why the C2 and C4 will be the 2 microfarad. And I'm going to write, so this is actually the 2 microfarad for C2, or I can write one more line for you so that you can understand. So it would be, I think it will be easier for you. So I should write C2 plus 1 over C5 plus 1 over C3. They are in series and their equivalent will be also the inverse 1 plus C4. C4 is also in parallel. So that's why I write down this equation over here. Right. Then I can find out what would be that C2, 3, 4, 5 equivalent. I write down C2, C4 and also C2, 3. They are in parallel. But C5 and C3 actually that series. So I have to convert that series equivalent. 1 over C equivalent. 1 over C3, 5 would be 1 over C3 plus 1 over C5. I write them in that in the short form. So what would that? This is actually the 2 plus, or you can write down this equivalent of C5 actually 4, right? C3 and C5 actually the 4. So 1 over 4 plus C3 is also 4, 1 over 4, and C4 is also the 2. Then you can find out that equivalent of 2, 3, 4, 5 is going to be 6 microfarad. Is going to be the 6 microfarad. Now C16, they are in parallel, so I'm going to add them together, which is 3 plus 3 is going to be the 6 microfarad. Then my C equivalent would be basically C16 into C3, 2, 3, 4, 5 divided by C16 plus C2, 3, 4, 5. Since they are in series, then I'll find out C equivalent in that case is basically 6 into 6 divided by 6 plus 6, which would be, and this is going to be basically the 3 microfarad. 6 into 6 is the 36 divided by 12. That's going to be the 3 microfarad. This is my C equivalent of this circuit. This is the answer number 1. What about the second one? Second one, they ask you the Q equivalent. I will use that formula, Q equal to, or Q equivalent actually that C equivalent into the V equivalent, right? The C equivalent the 3 microfarad, 3 into 10 to the minus 6 into the V is 20 volt, right? Then I can find out that the Q equivalent actually that 60 microcoulomb. This is actually that answer of the question number 2. So fine. So now the question number 3, they ask you what are the voltage across the capacitor 1, voltage and charges over here. I have to come up find out over here the voltage across this capacitor C1. First question. Second question, they ask me C2, voltage and charges. And third one, they ask you over here what is that charge across this capacitor and the voltage. Fine. If you closely observe this one, I can say I apply this 20 voltage. That's going to be that basically divided across the capacitor C2345 and C16. Since the capacitance is equivalent, then I can say they will be equally divided. That makes sense, right? We can also find out mathematically that's going to be the same. Fine. So for doing that one, I have to every time I will use that formula for this one. Say Q equal to the CV formula over here. For this case, Q equal to the CV. Now look at this. If I go in the backward, I could also say this is also would be my Q equivalent, right? That means I can say that Q equivalent is basically Q16, whatever the charge across the capacitor, 16, and also the Q2, 3, 4, 5, right? Because they are in series. We know that in series is basically the current is same, so that's why I can say that would be charge would be also the same. So they are in series. So fine. If I can find out, then I can use, look at this, I can say, since I'm going to find out that first actually that voltage, then I'll be able to find out basically the charge or whatever. If I could find out the voltage, then charge, then I'll be able to find out the voltage. Then I can write, say that Q16, the charge across the capacitor 1 and 6 over here. What would be that equivalent charge? That also going to be the equivalent charge. Also this Q2, 3, 4, 5. That's when I write it because they are in series. It's going to be the same. Fine. Then if it is the case, then I can write. Look at this. I could write, say that the Q equivalent in that case with that, which is C16 into the V16. Right, across the node, basically B and C, you can say that over here, which is 16, V and C. And V1 and 6 would be also the equal, right? Because they are in parallel. Whatever the voltage, if I say that voltage 16, that means the voltage across the capacitor C1 and C2, that is also the voltage that across the point B and C, right? That would be also the voltage individually the capacitor 1 and also the individually capacitor 6 because they are in parallel. We know that in parallel the voltages are same. I'm using that technique over here. Fine. Then I know that everything over here. My first job is find the V16 from there. I'm going to find out. So then I know the Q equivalent, which is that 60 microcoulomb. Q16, which is actually that 6 microfarad into 6 microfarad into the V16, or I can say that the V16 equal to would be that 10 volt, right? 6 micro be cancelled out, 6. So it's going to be the 10 volt. That is also the V1, and this is will be also that V6. I find out that voltage across the capacitor 1. Then charge I can write. So the charge Q1 would be C1 and V1. Sorry. So C1 actually, C1 is how much? This is 3 microfarad. And then I can write 3 into 10 to the power minus 6 and V1 actually that 10 volt. Then I can find out the Q1 would be 30 microcoulomb. So this is that charge in the capacitor 1, and this is the voltage across the capacitor V1, and V6 will be also that 10 volt because they are in parallel. It is find out in that way. You can also say that one because you have the 20 voltage. Your C2, 3, 4, 5 is 6 microfarad, and C16 also the equivalent 6 microfarad. So that means that these 20 voltage will be equally divided across that C1, across that equivalent circuit C1 and C6 is going to be the 10 volt, and this equivalent of C2, 3, 4, 5 will be also that 10 volt. Fine. I find out say Q1 and V1. Now the second question I have to find out across that capacitor C2 voltage over there. I have to find out that voltage V2 and also that Q2. So that's mean across these two nodes between A and B. That should be also the 10 volt, right? We can also find out mathematically over here. Say how? Say I'm going to do that. This is also logically I'm going to. So this is would be that 4. Again, I can say that V2 is basically voltage across that node A and B, right? V2 that should be over here, A and B. This is, I can write also that voltage V4, also that voltage V35. That should be all are equal because they are in parallel. And we can use another case that the charge across the node A and B, that should be also the Q equivalent because they are again in series over here. So this is actually the Q equivalent. So this is your point A, this is your point B, and this is your point C. So that's charges are equal over here. Fine. Then I can say that this Q equivalent, I can say that C equivalent of 2, 3, 4, 5 into that V2, right? Isn't the same? Then I can find out this V2 would be the Q equivalent divided by C 2, 3, 4, 5. Q equivalent is what? Which is actually that 60 microcoulomb divided by C235, which is equivalent capacitor is that 6 microfarad, right? So then I can write this is actually that 6 microfarad. That is again going to be that 10 volt, right? So that V2 actually that 10 volt again. I said it. So it will be equally divided since the capacitance are equal. This is also would be equal. You can say V2 equal. Then I can say that V4 equal V35 equal VAV is actually that 10 volt. This is actually that capacitance voltage across that combination. Now what would be that charge? So I can write say the Q2 actually that C2 into V2. What is that C2? C2 actually the 2 microfarad. So 2 into 10 to the minus 6 into V2 actually the 10. That's going to be the 20 microcoulomb. This is the charge on the capacitor 2. Fine. This is the. Now what about that capacitor 3 across over here? Now for this one, finding out, look at this. This is actually your 5. For that one Q3, you can write we know that the voltage across that AB equal V4 actually that V35 equal to the V2 which is the 10 volt, right? And we can also say that charge Q3 equal to the Q5 separately must be equal to the Q35, right? This is actually case. So this is actually your C5 and this is actually your C3. But across over here the voltage drop we find out which is with the 10 volt, right? It should be the 10 volt because these 2 point, which is actually that A and the B. Now I have to find out what is the voltage drop across over here. This 10 voltage now is going to be divided 3 and 5 again. Now for that one I have to find out this Q3 equivalent. So I can write Q35 would be C35 equivalent into V35, right? Which is V35 actually the V2, that way I can write C35 into that V2. Now what is that Q35? C35 actually I can write, they are in series. I should write 1 over C5 plus 1 over C3 inverse into that V2, right? Or you can find out this C35 would be 1 over 4 plus 1 over 4, so is inverse into V2 actually the 10. That will give you actually C35 would be also that 20 microcoulomb. Now I can also say that, so this equivalent charge across that capacitor which is C35 would be also that Q3, also would be that Q5, because they are in series, the charge will be the same. So I can say that Q3 equal to Q35, right, equal to the Q5 over there. So I can write Q3 basically 20 microcoulomb, and V3, that's I'm going to write Q3 actually that C3 V3, which is implies that V3 would be Q3 divided by C3. So Q3 actually that 20 microcoulomb, and C3, what is this capacitance? C3 actually that 4 microfarad, right? C3, let me check that one. C3 actually the 4 microfarad exactly. So C3 would be that 4 microfarad. In that case, you will find out that V3 would be 5 volt. That should also be equally divided because C3 and C5 are equal, right? Look at this, C3 and C4 actually the 4 microfarad. Then this will also do because the across this combination of C3 and C5 10 voltage is going to divide. That will be also equally divided because the capacitance are equal, 4 microfarad, 4 microfarad. So that's how you find out the V3 actually that 5 volt. Fine, I find out this is also answer number 4. Fine. Now the last one, they ask you what is the potential difference between that 2 point D and B. What is that? Can anyone say? Definitely is going to be basically that S is 0. The potential between this D and B is must be going to be the 0 because they are on the same point. You can find out from there. If you closely observe, this is, it has no, because that point I can connect it over here, and this is actually the same point. There are no potential drop between these 2 points. This is the same point, so that's why the difference between these 2 points will be basically that 0. Okay, thank you very much.